Hey, this is Travis, and today I want to talk about price optimization strategies. And what I want to show is something called the Van Westendorp Price Sensitivity Meter (PSM), and then also there's an extension to this which is called the Newton Miller Smith extension that I'll talk about a little later. But basically, Van Westendorp was a 1970s Dutch social scientist, and so he came up with this methodology for price optimization. And other researchers came along, the Newton Miller Smith, in the 90s, and then they extended his analysis. There are other techniques that you can use for price optimization, like Gabor Granger and choice based conjoint. Although those are more in depth and complicated, they are harder to collect the data. It requires more complex survey logic. And then also for choice based, it is much more complicated on the back end analysis. So Van Westendorp is a great analysis, and you can do it in actually 4 survey questions, and they're open ended. And so if we're coming over here, let me zoom in on these. See if we can see them all one at a time. Basically, you need to have a product predefined. So you have you already know what the feature sets are going to be, and you already know the main value proposition. So you can create kind of a visual, maybe picture and text based concept to show respondents in the survey, and then have 4 subsequent questions down here. The first question: at what price would you consider excuse me, would you consider product X to be priced so low that you would feel the quality couldn't be very good? This is called the too cheap price measurement. Next question: at what price would you consider product X to be a bargain, a great buy for your money? This is considered the cheap response. At what price would you consider product X starting to get expensive, so that it is not out of the question, but you would have to give some thought to buying it? This is the expensive response. And then the last one is: at what price would you consider product X to be so expensive that you would not consider buying it? This is the too expensive response. So we define a product concept based on these 4 different points for each respondent. For the Newton Miller Smith extension, you ask those 4 questions, and then directly afterwards you ask, how likely are you to purchase product X at, and then the answer that they gave in Q2. This is their answer for the price of the product that they would consider to be cheap. And then we ask the same question, another one, for that pipes in their answer from Q3, which is expensive, the expensive response category. What we're trying to do is get a proxy for their likelihood to purchase. What is the probability that they will purchase the product at those prices? And this allows us to create other visualizations that I'll explain later on. But basically, you can do PSM, the classic PSM with 4 survey questions, or you can do the PSM with the extension with only 6 survey questions. So it should go pretty quick. So before we move on, I just want to note a couple things for the survey programming aspect of this. We have 4 open-ended questions. This is text entry. So make sure that you set the field to numeric so that they can only type in numbers into this field. If they tried to type in letters, then the survey platform would return an error. Also, I already told you how these questions are structured. There's too cheap, cheap, expensive, too expensive. So the logic of PSM, which is the price sensitivity meter, is that as you go down these questions, the price should be increasing, right? It doesn't make sense if you say that $5 is too cheap and $4 is just cheap, right? It doesn't make sense to go down in price or stay equal. The respondent has to, to incrementally increase the price at each question. This is an assumption within the PSM model. A couple things you can do with that. You can either program survey logic to catch that in the moment when respondents are taking the survey. I bet Qualtrics probably has pre-programmed survey logic to deal with this. price optimization is a big component of their product. Also, and what I'm doing is just handling it on the back end. So I'll let the respondent put any numbers they want into these fields, and if the condition is not met in my back end analysis, then I discard those respondents, because, well, if they didn't meet that condition, then they probably weren't paying attention anyway to what to the answer choices they were giving. So this will improve the data quality, and it will ensure that we meet that condition for PSM. So I break the analysis down into two parts: the classic Van Westendorp analysis, and then I analyze the Newton-Miller-Smith data. There is something called the price sensitivity meter package in R, and it's awesome. It's a great out-of-box solution for this kind of pricing data. You pass the data to one function, and it creates a R object that is all the output that you need for the rest of our analyses and visualizations. You can imagine the questions that I showed you above, you can imagine them as vectors or columns in an Excel file. And I'm passing each of these vectors to their corresponding variables. The too cheap, this is question 1, right? Vector here. Question 2, question 3, question 4. Pi underscore cheap, this is the first Newton-Miller-Smith question. So this is question 5 and question 6. So this is a factor variable, and it's coded from 1 to 5. 1, 2, 3, 4, 5. 1 being very unlikely that I would purchase this product. 5 being very likely that I would purchase this product at the cheap and the expensive price that the respondent had listed. Anyways, this validate equals true. This is telling this function, this PSM analysis function, to discard any respondents who did not meet the PSM condition that I was telling you about above. How Q1 has to be less than Q2, which has to be less than Q3, which has to be less than Q4. If you can see here, the original data set that I passed this had 1,000 respondents, and there are 9 invalid cases, right? They did not meet this PSM condition, so we discard them, and we run all of the subsequent analyses with 991 respondents. So yeah, this is some printed output of the PSM out object, and it has everything we need stored in here. So I just go through one by one, looking at each component of this R object PSM out, and just we can talk about that and how it's used in the analysis and what they mean. So first here, PSM out data input. This is actually the data that was input in. So respondent 1, the price for that product X is considered too cheap is $10, cheap $13, expensive $31, too expensive $114. His or her likelihood to buy product X at $13 is very unlikely. His or her likelihood to purchase product X at expensive or $31 is neither likely nor unlikely. So somehow his purchase likelihood increased with the increase in price. It's a little strange, but maybe he's kind of like a luxury buyer and is concerned that products that are priced too cheap aren't good enough for him or her. I'm not sure. That's the data there. And these are the actual responses to the Newton-Miller-Smith questions. How likely are you to purchase the product at this price? And what we then do is we have an assumption about, based on their answer to the Newton-Miller-Smith questions, what is the probability of purchase, right? So a 1 being very unlikely to purchase is a 0% probability that the respondent will purchase. A 5 is a 70% chance that this person will convert. 4 is 0.5, 3 is 0.3, And so that's how they correspond to one another. We're literally just assigning our probabilities, and these are just a priori assumptions of ours that this is the probability that they will buy a product given their likelihood to purchase response in Q5 and Q6. You might have a problem with that, and that's fine, and you can actually change those values in this PSM analysis function above, but I just kept the default there. So this is the initial data, and everything that is calculated from now on is based on this data here. Again, 991 sample size. Next, I print PSM out data underscore Van Westendorp. This is the main calculation for Van Westendorp, and this is what we will actually use this data to create the classic Van Westendorp visualization. There is a price column, and these represent the range of prices that the respondents gave across all Van Westendorp questions from Q1 to Q4. ECDF stands for Empirical Cumulative Distribution Function, and that is a fancy word for basically the fraction, the cumulative percentage of respondents in the data set. Let's break that down even further here, and I have an example I want to show you. So let's look at the price 75 in particular. ECDF too cheap. This is the percentage of respondents that believe $75 or less is too cheap of a price. ECDF cheap, this one. So 16% of respondents believe $75 or less is considered cheap. 37% of respondents think that $75 or less is considered, and this is where you need to catch these things. So ECDF expensive, actually, so too cheap and cheap, they decrease, their cumulative distribution function decreases with price increase, and then the inverse is true for expensive and too expensive. So ECDF underscore expensive, this is how you interpret it. 37% of respondents consider a price of $75 or more to be expensive, and then only 9% of respondents consider a $75 price to be or more to be too expensive. So it's a little bit of a mouthful, and it's going to take a little bit of time to understand these, but we actually visualize these cumulative distributions in order to create the Van Westendorp visual that I'll show you below in a second. But just know that these stand for the percentage of respondents in our sample. Here is the main output for Van Westendorp analysis. Lower price range $40, upper price range $98. So our acceptable price range is from $40 to $98. The indifference price point is $67, and the optimal price point is $70. Let's visualize this now, and each of these price points we can see now on this visual, and they're actually defined by intersection points between the cumulative distributions. So the lower bound of the acceptable price range and upper bound of the acceptable price range are these two intersection points. Lower bound is the intersection between too cheap and not cheap, right? And it's the lower bound because if we go below this $40 limit here, then a greater percentage of respondents will think that our product is too cheap rather than not cheap. And it's kind of vice versa flipped for this upper bound here. Let's talk about optimal price point. It's the intersection between the too cheap cumulative distribution and the too expensive, right? So it's a meeting here. It's an intersection point. And Van Westendorp argues that this is the point of least purchase resistance for customers. So he argues that this is the optimal price point, and that's how it's defined. And determined. And this is the main analysis from a price sensitivity meter right here. We have the visual. We are plotting the four cumulative distributions on the visual. And then we show this shaded region here is the acceptable price range. And then we have these other two significant pricing points here defined as intersections between the cumulative distributions. Okay, so that was all Van Westendorp, kind of the classic analysis. Now let's talk about the analysis for the extension, for the Newton-Miller-Smith extension. Going back to our PSM out R object, we have data NMS, Newton-Miller-Smith. And so what we have is for each respondent, we have a probability for each one of their Van Westendorp prices. Q1 through Q4, we have a probability of purchase for each one of their price points. For each price point, we have the mean probability averaged across all respondents. And what revenue does is it multiplies this average probability in this trial column by the price. And this is a proxy for how much revenue we would expect this product to generate. So with this data, we can now go and generate the demand curves. One to maximize user adoption, and we'll use the trial column for that, and another demand curve to maximize revenue. Here's the demand curve to maximize user adoption. Here's the average purchase probability here on the y-axis, and the maximum here, and we look at the price and we see that at $61, the maximum number of respondents will purchase and use this product. So this is how you maximize user adoption. You're going to have to price it a little lower than the $70 that was optimal price point, which was suggested by Van Westendorp. And this makes intuitive sense to us that we can get more people to sign up if we decrease the price. And this is the maximum here at $61. The next demand curve is for product revenue and maximizing it. We have revenue on the y-axis, price on the x-axis, and we have this demand curve. And the maximum tells us the price at which we maximize revenue, which is 76. So just to wrap up, I want to talk about several things that we learned from the PSM analysis and then the extension from this. We learned from the PSM that the optimal price point for product X is $70. The acceptable prices, there's a range of acceptable prices which go from $40 to $98. We also learned from the Newton-Miller-Smith extension that pricing our product at $61 will maximize user adoption. And so if we're prioritizing user growth, then maybe we want to skew to the lower side, right? Instead of pricing at $70, which is our OPP, or $76, which maximizes product revenue. There are other methods for price optimization studies. One is Gabor-Granger, another is choice-based conjoint. Both of these are much more complicated and time-consuming from a respondent perspective and then also from an analyst perspective, the amount of time it takes you to analyze this data on the back end. So PSM and its extension is great. Gabor-Granger, you're going to have to know the price range ahead of time and then program that into the survey. So that's a little more of a limiting case. In PSM, we just needed to have a product concept so that the respondent can familiarize themselves with it, understand what the main value is for them, and then we give them an open-ended questions to put in the prices that they'd expect or want. Gabor-Granger is a little differently, and there's really heavy survey logic involved in it. Choice-based conjoint is great. It can help you also define your feature set. So PSM, you need a product concept with established feature set. Choice-based conjoint, maybe it's earlier stage in product development. You haven't finalized the feature sets yet. You have maybe, 5 to 10 different features that you're thinking about including in the product. And you want to know what would be ideal. Choice-based conjoint is great for this. It helps you optimize your feature set, and then you can also do price optimization on top of that. You can create price sensitivity curves, calculate price elasticity for your product, and brand equity curves with choice-based conjoint. So this is a lot of extra stuff. It's more interesting, but it comes with more work and more complexity. Thank you.